What is the SI unit of distance? Foot, meter, mile, kilometer. All these units are units of distance, but they are not all of them are the SI units. Only meter is the SI unit. A change in position with respect to a reference point is motion. We know that an object is said to be in motion if it changes its position with respect to a reference. Suppose that you are in a train. List some objects that make good reference points to determine whether or not the train is moving. Could be studying the motion with respect to the signs on the street, to parked cars, to trees. This means that you have to refer to objects that are at rest with respect to the ground. These are good references. You can refer to a moving car. It's okay. We can study this case. But which references are better than others? Those that are at rest with respect to the ground. Now use the illustration to answer questions 4 and 5. Suppose you're standing on the sidewalk. Describe the direction of your motion relative to the car and the airplane. So you can see that the airplane is moving to the left of the screen and the car is moving to the left of the screen. Or in other words, to the right of the man, if you try to imagine it. So they are moving in the same direction. You appear to be moving away. So relative to both the plane and the car, you appear to move from left to right according to the screen. Okay, so they are moving to the left and you appear to be moving far away from them in the opposite direction. So it's from left to right. Suppose you are riding in the plane. Describe the direction of your motion relative to the person standing on the sidewalk and the car. So relative to both the person standing on the sidewalk and the car, you appear to move from the right to the left. So the airplane is moving from the right to the left. If the man is looking at the airplane and you are sitting in the airplane, so you appear to be moving from the right to the left. And similarly for the car, you appear to be moving from the right to the left. If someone is sitting in the car looking at you at the airplane, moving from the right to the left, you appear to be moving from the right to the left too. Lesson 2, speed and velocity. What quantity can you calculate if you know that a car travels 30 kilometers in 20 minutes? So you have the distance, you have the time, you can calculate the average speed. Because average speed is equal to distance over delta t. Distance here is 30 kilometers and delta t is 20 minutes. But for sure, don't forget to convert these parameters or these values to the SI units. On a graph of distance versus time, the slope of the line indicates that of an object. So, as I mentioned here before, on a straight line of distance versus time, what does the slope represent? The slope represents the average speed of an object. A family takes a car trip. They travel for an hour at 80 kilometers per hour and then 2 hours at 40 kilometers per hour. So during the first hour, they were moving at high speed, which is 80 kilometers per hour. Then during the second 2 hours, they moved at lower speed, which is 40 kilometers per hour. Calculate the average speed of their car during the trip. We know that the average speed is equal to total distance over total time. So here we have two phases. Let's find the distance covered by the car during the first phase, which is equal d1 is v times delta t, 80 kilometers per hour times 1 hour equal 80 kilometers. Here we are given that the car keeps moving at 80 kilometers per hour for an hour, so this means that the car moves at a constant speed. So that's why we apply d1 is equal v times delta t, because usually v is d over delta t. This is the average speed. So v is equal to d over delta t. This is the average speed, but because the speed is constant, the average speed is equal to the instantaneous speed. So we can say that distance is v times delta t and consider the instantaneous speed. So it's 80 kilometers per hour times 1 hour, it's 80 kilometers. Now the distance covered during the second phase Now the second phase here. D2 is equal to V times delta T, 40 kilometers per hour times 2 hours, it's 80 kilometers. Add the distance to find the total distance. Total distance is 80 kilometers plus 80 kilometers is 160 kilometers. Now the average speed is equal to the total over total time. So it's 160 kilometers over 3 hours because we have 1 hour for the first phase and 2 hours for the second phase. So these are 3 hours. Then the average speed is 53 kilometers per hour. The graph shows the variation of the distance covered by a remote control car as a function of time. Use the graph to answer the questions. Question 9, sorry. To answer question 9. So we have distance versus t. First phase increasing, second phase the distance is constant, third phase increasing again, but it's clear that these two increasing lines have different steepness, different slopes, and we already said that on a graph of distance versus time, the slope of the line indicates the speed. So it's clear that the speed in this phase is different from the speed in the other phase here in the third phase. So during which time was the car moving the fastest? In the first phase, we can calculate the average speed in order to check during which phase the car was moving the fastest. Let's take the initial and the final points for each phase. So V final minus V initial over T final minus T initial. It's 1 meters per second. So this is the total distance covered during the first phase, and this is the duration of the first phase. So we get that the average speed is 1 meters per second. Now in the second phase, no further distance is covered, so 4 meters minus 4 meters. Over the duration, it started at 4 seconds and ended at 7. It is 8 here, sorry, so it's 8 here. Okay, so anyway, it will remain 0 because 0 over a number is 0 meter per second. There was no motion, no further distance is covered in the second phase. And in the third phase, we have the average is equal to 6 meters minus 4 meter equal 12 minus 8, so this is 0.5 meters per second. The car was moving the fastest from 0 seconds to 4 seconds in the first phase, since we have the greatest average speed here, and it's clear the line of D versus T is the steepest here. Acceleration. The rate at which velocity changes is acceleration. You can calculate the acceleration of an object moving in a straight line by dividing the change in the speed by the time. The graph below shows the speed of a downhill. So here we have the formula that we've been using. A is delta V by delta T. This is what we mean, the change in the speed by the change in the time. Now the graph below shows the speed of a downhill skier during a period of several seconds. Use the graph to answer question 12. Calculate the skier's acceleration. The given graph is speed versus time, so you have to check out if it's distance versus time or speed versus time. So here's speed versus time, and it's an increasing line, then the slope represents the acceleration. And I mentioned this in the summary. If you go back to the summary, here I said if V versus T is an increasing line, then the slope is the acceleration. So we have in this graph, in this one here, the acceleration. Calculate the skier's acceleration. It is slope, acceleration, rise over run. We can choose any 2 points. I chose for 8 meters per second, the time is 2, and for 4 meters per second, the time is 1. So we subtract them, we get 4 meters per second squared. A ball is dropped from a window and takes 2 seconds to reach the ground. It starts from rest and reaches a final speed of 20 meters per second. Calculate the ball's acceleration. So we are given the duration, we are given the initial speed, it starts from rest, and we are given the final speed. We are asked to calculate the acceleration. Apply the formula V final minus V initial or delta V by delta T. This is 20 meters per second minus 0 meter per second over 2 seconds is 10 meter per second squared. The distance versus time graph is for two runners, Jen and Anne, in a 50-meter race. So the orange graph is for Jen and the gray one is for Anne. Explain whether you can describe the variation of the speed of each runner as a function of time. Given the graph of a distance versus time, describe the speed of the runners. So although we are given d versus t, but if I again go back to the table to the summary, we know that when d versus t is an increasing straight line, then b is constant. So since the graph of distance versus time is an increasing straight line for both runners, then the speed of both is constant. And of course, they are moving on a straight line in one direction. Now, without doing calculations, compare the speed of the runners, explain. Again, I mentioned that before, that for the graph of d versus t, the slope of the line represents the average speed of the moving object. So the line for d versus t of Jen is steeper than that of Anne. This means that the slope of the orange one is greater than the slope of the gray one, and thus the average speed of Jen is greater than Anne. So the slope of the line that describes the variation of the distance as a function of time represents the average speed of motion. The graphical line according to Jen is steeper, corresponding to Jen is steeper than that corresponding to Anne. Thus, Jen moves at a greater average speed than Anne.